All right, guys, we are back. We are going to now apply our last piece here. We've talked about our kind of macro level pieces with our solutions, right? Our homogeneous versus heterogeneous, what we would see if something is soluble or insoluble. We've then also talked about our micro level, right, the molecular level, where we're talking about, hey, what's happening to these particles for something to dissolve, right? Our water particles or our solute particles have to interact with good, favorable intermolecular forces or similar intermolecular forces and be able to pull those solids apart. So we've talked about those. Now, of course, right, when we've talked about solubility, we now need to start applying our math and doing our concentration calculations, okay? So calculating concentration, we have formulas for each of these, but something that I want to point out is that we have these brackets, okay? So brackets like that are square brackets. This represents the concentration, okay? Most often in chemistry, we actually use molarity, okay? So molarity is a concentration, and it is moles of solute over, solute over liters of solvent, okay? So it's pretty easy as long as we can calculate the number of moles of our solute. As long as we know the liters of solvent, we can calculate our molarity. We can use this as a conversion factor. If we know the molarity of something, right, we can know how many liters we maybe have, or we can know how many moles we have in there. We can the big piece with this is that we need to make sure that we use moles of solute and liters of solvent. Okay, so we got an example here. What is the molarity of a solution that contains 4 moles of NaOH in 0.5 liter solution? Well, it's real easy here to just put in our units where we need to, right? So 4.0 moles of NaOH over liters of solvent, well, 0.5 liters solution, well, so we're going to say liters of solvent there. What does that equal? 4 over 0.5, 8. So we would say that it is 8 molar, okay? So 8.0 molar, okay? That big M represents molarity, okay? We'll see this often, but whenever I'm trying to figure out math problems, right, questions like this, what I always like to do is I like to write it as moles over liters, right? So 8.0 moles over liters. That way I'm not hiding the actual units that are in there, okay? So by writing, anytime we see molarity, writing it as moles per liter, that can help us identify what units we need to get to, okay? The next one we're going to talk about here, we're really just going to talk about parts per million. Parts per million is probably the most common concentrations that we actually see in the general world, right? We see this all the time. If we're talking about environmental sciences, right? If we're talking about our air quality, if we're talking about our water quality, right? We oftentimes talk about parts per million or parts per billion, okay? So the formula for that, right, is the part, right? So number of parts divided by million others, right? It's kind of vague here, right? So we're not really going to do many calculations with our parts per million at all, okay? We're not going to do that, but it is one that we should be aware of, okay? Then when we come down here, we have 2 other percents, right? We've talked about percent by mass before. Percent by mass is, of course, right, part mass divided by whole mass, and then times 100, okay? So we've talked about this before, right? I'm just kind of reminding us that this is something that we could do. So we would want to do 2.5 0.50 grams of NaOH here over the total mass. Well, my total are those two added together, so over 52.50 grams total. Hey, what does that equal? Right down there, 4.76, okay? All right, last one here, percent by volume, okay? So percent by volume is, again, part over whole, except that now we're doing it by volume. So down here, right, if we look at this question, what is the percent by volume of alcohol if 50.0 milliliters of ethanol, ETOH, is diluted with water to form a total volume of 300? Well, so it's going to be over 300 milliliters. 50 over 300, 16.7%. Okay? So these two, again, are things that we see, we know that we see them regularly, but in chemistry, right, we are mostly going to be using molarity. Okay? So molarity, right, it is moles of solute over liters of solvent. I'm also going to throw in one other piece here that we can talk about. We're going to talk and use this actually later. Molality. So molality is little m, right? This one was big M for molarity, little m for molality, and this is moles of solute per kilogram of solvent. Okay? So this is very, very similar, right? But it is a little bit different. Okay? So we have to make sure that we kind of pay attention to these. What we're going to start with is molarity, okay? And it's actually what we're going to use most often in chemistry. We will see one example of molality as we go through, okay? So what I'm going to do is I'm going to flip over to our worksheet, okay? So this is phases, waters, and solutions, 6.5. It's all about our concentration, right? We're going to get some practice with our molarities and our percent by mass. So this is molarity, and this is percent by mass. Okay, so we can use these two equations whenever we are going through this. Okay, so if we read this first question, let's think about this. All right, how many milliliters of water? I'm going to underline that because it's saying, hey, this is my question that I'm going to use. Must be used to make 1.36 molar solution that contains 8.56 moles of NaOH. So I read this question, I realize, oh, my molarity is really going to be useful here. So my molarity question or equation is what I'm going to use. So I'm going to go 1.36 molar, right? That's my big M. I'm going to change that, and I'm going to write it as moles over liters. And that's going to equal, well, moles of solute. This is going to be my moles of solute, 8.56 moles of NaOH over some volume, right? Liters of solution. So I should just be able to solve for liters here, okay? Another way that I can actually do this is start from my unit that only has a unit on top, and then use my molarity as a conversion factor, okay? So this is kind of similar to our stoichiometry calculations that we've done before. So I'm going to show us that as well. So our 8.56 moles of NaOH, I want to make a solution, right? And I'm going to do a conversion factor here. So I want to make a solution that's 1.36 molar. So I'm going to show that my units cancel, right? So I'm going to put moles of NaOH on the bottom, which means that if I'm going to use my molarity here, I want to get to my liters, right, or milliliters here, right, liters of solute or solvent, right? Well, moles per liters, right, I'm going to put my 1.36 on the bottom, 1 liter on top. And that's going to get me to liters right away, right? So then I could actually put on a second conversion factor. So I'm actually going to rewrite this so I can show that we put them all together. Moles of NaOH, I'm going to put on 1.36 moles of NaOH per 1 liter. And then I'm going to put a second conversion factor on here where I'm going to say, well, 1 liter is 1,000 milliliters. Okay? So if I do my equation like this, where I show my units canceling, I can actually convert all the way to the unit that I actually want. Okay? So if I go through this, right, it's the exact same math. If we do it this way here, using our equation at the top, whoops, or if we do it this way here, where we are converting our units, okay? It's the same math. It will get you to the same answer, okay? So for this, we would do 8.56 divided by 1.36 times 1,000, and that would give us our answer in milliliters, okay? So that's kind of how we can go through these this worksheet. We've got lots of practice with these, okay? Because our molarity is really important as we move through to the next units, okay? All right.